So just jumping into this question 5, the reason I've picked this one is question 5J is it's a good example of substitution, and we talked about here we've got x equals 2. We're looking at x values here. Now, to do this integral, ideally we're either going to look at like a chain rule or we do substitution here. And when we do substitution, there's two possible options we can do. So we'll do it first with, we will leave the x bounds for the first option. So if we do this next, we're going to get x equals 2 to 6, and this is pretty much 2x minus 3 to the negative 1/2. So I've just changed the form of this equation, still dx there. And so we're looking at this, we would have u equals 2x take 3, and then du dx is the derivative of our u function up here. We're going to get, that's going to equal 2. So it means I need to get a 2 into this function here. So I'll just do my next line here. Now, I would usually just put a half out the front, but I'm going to do them together. So if I do a half times 2, I'm technically timesing this thing by 1, so I'm not changing anything. So I've got 2x minus 3 to the negative 1/2 dx. Now, in this space here, what I'm going to do is I'm going to move that half out the front, and I've got 2x minus 3 to the negative 1/2, and then I've got this, it's sort of times by that 2 that we had, and then dx. Now, the reason I've done this is it allows us to do our next line, and I've got a bit slack here. I've got x equals 2 to 6, x equals 2 to 6. And so my next line here would be a half, and this is the integral of x equals 2 to 6, and this is u to the negative 1/2. The 2 here is du dx, and then we've got with respect to x, so we can rewrite this as half the integral x equals 2 to 6, and we've got u to the negative 1/2 du. Now, the reason we're going to go two sort of ways here. So this first steps, you can do it pretty much both the same way in this particular spot. And we will do, I'm just going to bring the u back down. So we had, just so we're aware, I'm going to put this just here. We just remember we had u equals 2x take 3. Now, we'll do it just the way without changing our variables. So at the moment, we would do the integral of this. We would have, we're going to leave the half out the front, and then the antiderivative of u to the negative 1/2 is u to the 1/2 over the 1/2. And then we've got x equals 2 and 6. And so realistically here, we could cancel out these two halves. So we've got a half and a half there, or we would multiply and that becomes 2. And so the next step here is we need to sub in here. This now needs to become x because we don't have u values out here. So if we've got that, we're going to be looking at square root is what u is, u to the 1/2. So we've got the 1/2, I've just put the square root in for that just because we're going to calculate it. And u is 2x minus 3. So let's put that back in. 2x minus 3. Okay, and we've got x equals 2, 6. Now I can sub those values in. So this is going to be equal to the square root of 2, 6 minus 3. And then this will be minus our lower bound, which will be square root 2 times 2 minus 3. All right, which will equal 2 times 6 is 12, minus 3 is 9. We've got root 9. Minus 2 times 2 is 4, minus 3 is 1, root 1, which equals 3, minus 1, which equals 2. Okay, so this way we didn't change our values here, but we want to show you that we can do it. So realistically, in this next step here, we would do the integral the same way here, but I'm going to rewrite this. So we've got half, and then we've got the integral, and now instead of x equals 2, if I sub x equals 2 in, so x equals 2, u would equal 2 times 2 minus 3, which is going to be 4 minus 3, which equals 1. And x equals 6 would be u equals 2 times 6 minus 3, which equals 9. And so what I can do here is u equals, our lower bound here, this lower bound of 2 equals 1. So I can go u equals 1, and then our upper bound is 9. And then I've got u to the negative 1/2 du. We can now do our derivative. So this would equal 1/2. And this was u to the half, the antiderivative of negative half, over 1/2. Okay, and then we've got u equals 1 to 9. And then we could, maybe I should have written this 1/2. Now, remember that divided by 1/2 is the same as times by 2, so this would be 2 square root u. So they cancel out. And we've got u equals 1 and 9. Okay, so it's the upper bound minus the lower bound when we sub it in here. This one here is square root 9 minus square root 1 equals 3 minus 1 equals 2. So there are two different methods of doing it. Now I should put a bit of a line down the middle. So you can pick either way to do those there. We'll jump to the next one here. Oh, that's a little bit off to the side. Oh, I haven't set this one up yet. I'll quickly do it. So we're looking at the next one here, and I should have written it out before doing a video, but we're looking at K now, because K is a good example to do for these ones. So just let's quickly type K in. So in our textbook, K is the integral of 0 and 1 of e to the 1 minus x dx. Okay, and so the reason we would... I suggest you have a go at this before. So if you're watching this and you're thinking, oh, I can have an attempt at this, please do. But if not, watch along, and once you think you've got past a tricky bit, have a go yourself. So in this one here, we're looking at, this is substitution again. We've got this function up here that makes it just that little bit more difficult. So we've got u equals 1 minus x. And so we've got du dx equals negative 1. So let's jump to our next derivative. So this is x. Hang on a sec, I don't usually do it in black. Let's change to blue so you know what I've been doing in the video. So x equals 0 to 1, e to the u, and I need a negative 1 in here. So I'm going to do negative 1 and negative 1, because if I have one of them, dx. Now if I move one out the front here, I can do the negative integral of x to the x equals 0 to 1 of e to the u. I've got one more negative 1 left in here, dx. This here becomes du. This is du dx, so I can do my substitution. So I have negative x equals 0 to 1 e to the u du dx dx. This changes out, so we're now ready to do our integral here, and minus x equals 0, 1 eu du. Now, I'm going to pause just here for a minute, and we're going to quickly put in our u equals 1 minus x. U equals 1 minus x, which means our lower bound x equals 0. 1 minus 0, so u here equals 1 minus 0, which equals 1. And then our other bound here is x equals 1, which means u equals 1 minus 1, which equals 0. So we've got that sorted. Let's do it in terms of x first. So we've got that. So we've got this negative 1 that's sitting out the front, and then we've got the derivative of eu is eu. And then we've got x equals 0 and 1. I now need to change this back to x's so I can sub it in. So e to the 1 minus x equals 0 and 1. This becomes negative. Our upper bound is e to the 1 minus 1. And then we've got minus e to the 1 minus 0, which is going to equal, should be doing equal signs here. Sorry, I'm getting a equals. Okay, that was just me being a bit pedantic. So this next step here means I've got, this is going to equal negative e to the 0, and then negative times a negative is going to be plus e to the 1, which means I've got, this is equal to e to the 1 minus 1. Now that is approximately equal to, so I've got my graphics calculator and I've got a shift e to the 1 minus 1, and it's approximately equal to 1.72, and that is 3 sig figures. Okay, now let's quickly do it the other way. So if I wanted to here, I could have changed this to be equal to negative, the step above it, not this one here. We want this one here. We could have changed this to be negative e to the u, and our lower bound here was, so x to the 0 turned into u equals 1. So we would go u equals 1, and then x equals 1 turned into u equals 0. So we put the 0 up here, and we can now write this as e negative, and then we've got e to the 0 minus e to the 1, and that becomes e to the 1 minus e to the 0. So you get the same answer either way, but it depends on how you want to do this. So e to the 1 minus 1. All right, thanks guys.